now we are available again. So because of few technical issue, we cut down it on first lecture only. Now we will proceed with the next two lectures. Okay. So let's continue. Cut down it on first lecture only. Now we will proceed with the next two lectures. Okay. Okay. So let's continue. Okay. So if you remember, we have completed these all things on the first lecture. We are on the question this 50C25. So we should be showing that find the number of zeros. So we have to find the number of zeros, isn't it? So for that 50C25 is there. So I am giving you all few time to just think on that, and then after that I will discuss. Okay. Okay. Then I will discuss. So let's continue. So so 50C25, it could be written as 50 factorial upon 25 factorial 25 factorial. Okay. Now we'll go with 50 factorial as 2 to the power a, 3 to the power b, 5 to the power c, 7 to the power d. Okay. 7, 8, 9, 11 to the power e, 13 to the power f, 14, 15, 16, 17. So these all are prime. 17, 18, 19, ij. It should be j. Okay, it's a j. 20, 21, 23, k. Okay. 24, 25, 26, 27, 28, 29, 30, 31. So for this much we don't have to go ahead. And 25 factorial will be somewhere 2 to the power a, 3 to the power b, a1, b1, 5 to the power c1, 7 to the power d1. Okay. D1. And what will happen? Let's check it. 11 to the power E1, 13 to the power F1, 17 to the power I1, 19 to the power J1, 23 to the power K1. It will go only up to this much. Yes. So first we'll calculate by 450. 450 power of 2. We'll get 50 by 2 greatest integer plus 50 by 2 square. Or can we follow some trick? Can we follow some trick? It is 50, 49, 48, 47, 46, dot dot dot, 3, 2, 1. And we have 25 factorial and the next 25 factorial. If we see If we take 2 common from 2, 2 common from 4, we are going to get 25, 24, 23, dot 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 1. And this is 2 to the power 50, 2 to the power 25. Yes? And the next left term is what? 49, 47, 45, dot 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 3, comma 1. So if you see 125 factorial got vanished, cancelled. Yes? We are left with second 25 factorial. Okay? So what will happen now? Now what will happen? Let's see. There is total 25 term. At the bottom we have 25 term. So if we go with 25, 24, 23, 22, 21. Okay. So it will go up to 3, 2, 1. And what will happen? In this we are trying to see. Okay, so we got a new trick. Okay, we have to find number of zeros at the end. So we'll find the power of 2. Okay, the power of 2 in 50 and the power of 5 in 50. That we can do. This is 50, 2 to the power 4, 50, 2 to the power 5, 50, 2 to the power 6. So 2 to the power 5 is 32, 64. So this is going to be 0, greatest integer 0. So if you see, it is 25 plus 12 plus 6 plus 3 plus, this is 16. 16 3 are 48, 32, 1. So we are overall getting 10, 12, 22 plus 25, 47. Okay. And then 5 divisible by 5. We have to check that. 50 by 5. 50 by 5 square, and 50 by 5 cube is going to be 0. This is 0 point something, so we are getting somewhere 50 by 5 10, 50 by 25 2, which is 12. So what will happen? We have 12 5 and 47 2. That means only 5 multiplied by 2 will become 10. So if we have 12 5 and 2 to the power 47, can we say it is 10 to the power 12 into 2 to the power 35? So total number of 0 at the end of 50 factorial is 10 to the power 12. So now we are going with 25 factorial. So in 25 factorial we'll see the 2's. Okay. So it is 25 by 2 plus 25 by 2 square 25 by 2 cube, 25 by 2 to the power 4, and 25 upon 2 to the power 5. So this is 0, this is 12, this is 6, this is 3, this is 1. Overall it's 10, 22. Now we want 5. In 25 we want 5 power, okay? Which is 25 by 5 plus 25 by 5 square. So we are getting only somewhere 5 plus 1, 6. So if you see here, okay? So if you see here, okay, you will find that what is going to happen. Okay, so what is going to happen? See, so 50 is what? 10 to the power 12 into 2 to the power 35, and whatever they are there, they are all primes. And 25 is what? 2 to the power 22 whole square, 25 factorial whole square. So if you see, it is 10 to the power 12, and it's like 2 to the power 32, and we have 10 to the power 12, 2 to the power 35. So all this will get cancelled, then we are getting no 0. So 10 to the power 0, and we have 2 to the power 3 dot dot dot, all are prime. So number of 0 at the end is 0. So no 0 is available there. No 0. So this is the way we have to solve. Okay, so there is no 0. So we are moving ahead. So the last non-zero digit is of 5 is. So last non-zero digit of 5 is. So what will happen? 25 factorial will be multiplied as 25, 24, 23, 3, 2, 1. They are saying that in this, so as we solved in last question, 25 factorial was 2 to the power 22 into 5 to the power 6. And then it would have been somewhere 7, 7 to the power C, 3 to the power B, okay, 2, 3, 5, 7, 11 to the power D, and 11 to the power B, 13 to the power E, 15, 17, 17 to the power F, 19 to the power I, okay, 19, 20, 21, 22, 23 to the power J, and then we have 24, 25. Okay, so we have this much prime factors for 25. So we already know 2 to the power, 5 to the power. Now we are calculating for 7. So 7 is what? 25 by 7 25 by 7 square, so it is somewhere going to be 0 only. So overall we are getting 7 threes are, and we are going with now power of 11. So 25, 11, 25, 11 square. So this is also going to be 0. We are getting 2. Now we are moving to 13. So 25 by 13. 25 by 13 square. So this is going to, the greatest integer is going to be 0, and this is 1. Okay. Now we are going to 17 power. So this is 25 by 17, 25 by 17 whole square. So this is going to be 0, and this is 1. And if you go with the power of 19, it will come out to be 25 by 19, and the other one is 0 itself, isn't it? If you go with 23, so it is simply 25 by 23, which is 1. So you can find that these numbers are coming in the form of 2 to the power 22, 5 to the power 6, 7 to the power 3, 11 to the power 2, 13 to the power 1, 17 to the power 1, 19 to the power 1, 23 to the power 1. So we have to calculate the last digit, last non-zero digit. So it will have around 10 to the power 6 0, and after that we have 2 to the power 16 and 7 cube. 7 cube, the last digit will be 7 7 are 49, 9 7 are 3, 63. So 3 3 9, 9 7 are 63, 3 9 are 27, 7 3 are 7 3 are 21. So from here we are getting last digit as 1, and 2 to the power, we have 2 to the power 16. So if you see 2 to the 4, so 2 to the 4, 4 4 ja 16, and 16 6 ja. So last digit is going to be somewhere 6 and then 10 0. Okay. So the last non digit, the last non zero digits is 6. Okay. So this is the way we have to solve. For solving this type of question, okay, so we already solved this type of question, so I am giving you some chance to solve it again. 50 C 36. Okay, so this is 50 factorial, 36 factorial, and then 14 factorial. Okay, so we have to find that whether it is divisible by 5 5 square, 19 19 square, 5 cube. So this is what we have to find. Yes. So for that, what will we do? What will we do? We have solved this type of question earlier. So we see that 50 into 49 into dot 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 37 into 36 factorial upon 36 factorial into 14 factorial. 36, 36 will get cancelled. Now we are left with 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40, 39, 38, 37, 36, 37. We are left up to 36, okay? And at the bottom, if you see, we are going to have 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? Now what will happen? If you see 14 threes are 13 threes are okay, 12 fours are 11 44s are 10 fours are 9 fives are 8 8 4 twos are 8 2 twos are 2 threes are 6 7 sevens are 5 5 cancel 4 4 cancel 3 3 cancel 2 25s are okay. So in this type of question, if you go through vector factorial form, it will be difficult for you. It will be difficult for you, or it may not be difficult for you. So we'll solve using that method also. So if you see here, we have 25, 7, 47, 46, 43, 41, 38, 37. So 19 is dividing, 38 is divided by 19. So 19 is correct. And 25 is getting divided by 5 square. This is correct. For 5 cube, we are not finding any 5, isn't it? Okay. And 19 square we are not getting. Second method, if we go with 50 factorial, we are asked about 19 and 5 only. So we'll go with 50 by 19 and 50 by 19 square. I think which is going to be 0. So it is 2. Now again we'll go for 5. So 50 by 5. 50 by 5 square. 50 by 5 cube. So this is going to be 0. So we are getting 10 plus 2, 12. Now we are going with, we got 5, we got 19. Now we are here 36 factorial and 14 factorial. So for 36 factorial, we are going for 19. So this is 36 by 5. 36 by 5 square. So this is 7 plus 1, 8. And if we go with 36 by 19, and 36 by 19 whole square is 0. So this is 1. Okay. And now we are going with 14 factorial. In 14 factorial, the power of 19, which is 14 by 19, which is 0. And if you are going with the power of 5, which is 14 by 5, which is 2. So what will happen overall? This part is going to be 19 square into 5 to the power 12, and 36 is 5 to the power 8 into 19 to the power 1. Okay? Okay? And if you go with 14 factorial, we are just getting 5 square. So we can say that our output is somewhere 5 to the power 2 into 19 to the power 1. So it is divisible by 5 square. It is divisible by 19. So B is the answer. Okay. So let's move ahead. Now we have divisibility of number. So these are just basic. You have to know to solve multiple type of questions. Okay. Okay. So divisibility of a number. So we'll put it divisible by. So we'll put number this side. Okay. Divisible. Now if we go with 3. Okay. So what will happen? Sum of digit. Sum of digits divisible by 3. Okay. If you go with 4, last two digits. So like sum of that, this is for example, if you take it is 5 5, last digit will be 2, 5 5 0. So last digit is what? Even. Last digit is even. Okay. So last digit is even. So 5 5 4. So last digit, if you see, it is even. So it will be getting divided by 2, isn't it? If you go this with this one, so if you put 1 1 1, sum of the number is what? 3, and 3 is divided by 3. Yes. So sum of the digit, if it is divisible by 3, then this is the condition for a number to get divisible by 3. Okay. For a number to get divisible by 4, last two digits should be divisible by 4. Okay. For condition of 5. last digit should be should be 0 or 5. This is the condition for this to happen. Okay. Condition for 6. A number to get divisible by 6. It should be last digit to be even. Okay. And sum of the digits sum of the digits to be divisible by 3. Divisibility criteria for 8. Last 3 digits to be to be last 3 digits to be divisible by 8. Okay. Now to get 9 criteria, last last note, sum of the digit okay, it will be sum of digits to be divisible by 9. Now if you go with the criteria for 11, then sum of even position number minus sum of odd positioned numbers to be divisible by 11. So if we have example, for example, if you have 1 2 1, so on even position what we have, this is one position, this is second position, this is third. So on even position we have 2 minus sum of the digit on odd position. So we have 1 at one position, 1 at third position. So 1 plus 1 is 2. 2 minus 2 is 0. So 0 is divisible by 11. So this number is divisible by 11. So this is what I am trying to say. Okay, so we have one more condition. Condition for 25. Okay, so condition for 25. We have one more condition. What is the divisibility criteria of 25? So last two digit should be divisible by 25. If last two digit is divisible by 25, then that number is divisible by 25. So these are the important criteria. I think you should remember it. Okay. Now we are on lecture 2. So we went through all the basic methodology, all the process and everything. अब ये समय है कि हम लोग परमुटेशन को समझे, परमुटेशन और कॉम्बिनेशन को। इनिशियली हम लोगों ने नॉर्मल काउंटिंग किया, अब परमुटेशन और कॉम्बिनेशन को हम लोग समझे, है ना। सो दिस इज व्हाट, सो लेट्स कंटिन्यू। ओके, द मीनिंग ऑफ परमुटेशन देखो। सो फर्स्ट वी हैव टू अंडरस्टैंड द मीनिंग ऑफ परमुटेशन। ओके, so meaning of permutation is total numbers of arrangements. If you see the meaning of permutation, it is total number of arrangements of given cases. Okay, so total number of arrangement of the given cases, this is the meaning of. Okay, so what do you mean by cases? So cases meaning given cases taken some at a time or all at a time. Okay, so this is the meaning of permutation. For example, if we are told that there is, example, if we are told that we have 5 different objects, so find their arrangement, find their arrangements. So what will happen? We will simply write 5 capital P5. Okay, 5 P5. Okay, so 5P5 will be saying that it is the total arrangement for 5 different objects. So what will happen? How do we write mention 5 PR? So 5 PR, 5P5 is written as 5 factorial upon 5 factorial 5 minus 5 factorial into what is here? It is written 5 factorial. So if you see, it is 5 factorial, 5 factorial, 0 factorial, 5 factorial, which is 5 factorial, because this 5 will cancel, 0 factorial is 1. Okay. If we are telling you second example, okay, out of 5 objects, 5 different objects, okay, 5 different objects, 5 different objects, select 3 and find their arrangements. So if such type of question is given, we will simply do 5P3. This is enough. That means we selected 3 object out of 5 and we did arrangement. So this is what? 5 factorial upon 5 minus 3 factorial. This is it. Okay. So we can simply say that it is 5 factorial upon 2 factorial, which is what? This is 5 into 4 into 3 into 2 into 1 upon 2. If you calculate, it is 60. So there is 60 way of arrangement. Okay. Okay. So let's move ahead. So what will happen now? Now we will go with the theorem. So I think whatever example we studied before, है ना, वो सारे examples enough है इस theorem के लिए. है ना. तो पहला थ्योरम है. So the trick to solve different arrangement. So in first theorem, if we are told that number of permutations of an distinct things taken all at a time. So if some question is saying number of permutation of and distinct things taken all at a time, then what will happen? We'll simply write NPN. So this is the answer. This is the answer, NPN. So what does that mean? This means simply n factorial upon n minus n factorial, which is nothing but n factorial upon 0 factorial, which is nothing but n factorial. Okay. So this is what it is. And n factorial could be more elaborated is as n minus 1, n minus 2. This will go up to 3, 2, 1. So this is how it is going, isn't it? Okay. So this is the answer. Now let's move to theorem 2. What does the theorem 2 speaks? So theorem 2 is saying that, okay, it is saying that agar if you are told that permutation of number of permutation of n distinct things, number of permutation of n distinct things taken are at a time. So we have n distinct object. Now we have to take r at a time. So what are the total number of permutation? So permutation meaning arrangement. So if such questions are asked, we'll simply write n p r. This is the answer. Okay. So this is, so the solution for this one will be n factorial n minus r factorial. This is the solution. Okay. So if I ask you a simple question, a basic question, so the question is this: in how many ways, in how many ways 5% 5 persons be made to occupy one. Question one is what? 5 different chairs. So if you think, we can normally say that we'll make 5 people sit on the chair and we'll do their arrangement. So 5 people will sit A1, A2, A3, A4, A5. 5 people will sit in chair. Okay. So what will happen? 5 people will sit and there will be arrangement. That means overall we are doing the arrangement of 5. So permutation of 5 distinct thing is what? 5 P5, as we know using theorem 1, which is 5 factorial upon 5 minus 5 factorial, which is 5 factorial by 0 factorial, which is 5 factorial, isn't it? Second, Okay, second question is, so we have in how many ways 5% can be made to occupy three different chairs. Okay, so now we have only three chairs and we have five people. So can we say that out of five we are choosing three distinct objects and we are doing their arrangement? So can we say it is theorem 2? Number of permutation of n distinct things taken are at a time. So number of, so from five chair we are taking three at a time. So it is what, 5p 3, which is 5 factorial. 5 minus 3 factorial, which is 5 factorial by 2 factorial. We know that this is 5 4 3 2 1, and this is 2 into 1, and hence it is what, 60. So we got the answer. Okay, let's move ahead. Now see, we have continuously, I think we are going to have the questions. So we have a few questions to be solved here. So we will be solving this question. How many three digits can be formed using 1, 2, 3, 4, 5 without repetition of the digit? How many of these are even? So one thing is that three places are available, five numbers are there. So if you remember theorem 2, so if from theorem 2, five distinct objects are given and we have to take three distinct objects. So out of five distinct objects, out of five distinct object taken three at a time, which is what, theorem 2. Yes, so using theorem 2, can we say the answer is 5p 3, which is nothing but 5 factorial, 5 minus 3 whole factorial, which is 5 factorial upon 2 factorial, which is nothing but 5, 4, 3, 2, 1 upon 2, which is 60. So this is the total number of three digits formed without repetition, because all are distinct, isn't it? Second one is how many of them are even. That means we have three digits. So when they are asking directly question how many of them are even, that means Here we should be having 2 or 4, isn't it? And here could be any of the left number. Okay, so if we put last number to be 2, last number to be 2, we are left with how much number? We are left with 1, 3, 4, 5. So we can keep any number out of 4. For example, we choose 4. Now we are left with 1, 3, 5. We can choose any number out of 3. Yes. Now second, if the last number is 4, we are left with 1, 2, 3, 5. So here we have only 4 options. For example, if we choose 3, here we have only 3 options. So overall 3 into 4, and here 3 into 4. Overall all we are getting 12 plus 12, 24. So total number of even numbers are 24 in the 3-digit numbers. Okay, and total number of 3-digit number possible are 60. So this is the difference I am trying to show you all. So let's move ahead. If all letters of quest are arranged in all possible ways and put in dictionary order, then the rank of the word of the given word. So we have Q, U, E, S, T. So we are told that a dictionary is containing words which are having only these letters. Like if you find any word in the dictionary, they are containing only this much words. Okay. And I think they should be unique because they are arranged in all possible ways. So I will have to check whether they are unique or not. Okay. So what will happen? First we will choose. So if you write in increasing order, first will come out to be E, Q, A, B, C, D, E, F, G, H, I, J, U, P, Q, R, S, T, U, S, T, U. Okay, S, T, U. So the first word in dictionary will come out with E, and we will have last 4 term left. The first term is this, second, third, fourth, fifth. So what will happen? After E is chosen, we have 4 words. So here we can have any one of the 4 words. Then if one word is chosen, we can have any one of the 3 words. If this word has been chosen, we can have any one of the 2 words and then 1 words. So this is somewhere 4 factorial, 4 into 3 into 2 into 1, 4 factorial. Now, first word was starting with E. So we did all the case of E. Now we are going with the first word as Q. So we have 1, 2, 3, 4, 5. So if Q will shift here, then we'll have If Q is the first word, then we have this way arrangement as T, U. So we have E here. Then we can say that if we took Q, E together, we have 1, 2, 3. Three numbers possible. If we choose any one of this, we have two such number possible. If we choose any one of them, we have now one number possible. So this means 3 factorial. Now we will have Q here. Now we'll put QUEST. Yes. So we'll put S here. Now we have this thing. So QS, it will go as UE. QS is the first term. It is go as ETU. So we can have three numbers and then two and then only one, which is 3 factorial. Now we go with QT. So it is QT. It will go as ESU. Okay. So if we have QT fixed, so what can happen? We can have any number out of 3. If we, for example, if we choose this number, we are left with only 2 number. If we choose this number, we'll put only one number, which is 3 factorial. Now, it's we did QS, we did QT, we did QE, we did QS, we did QT. Now it's a QU. So QU is there. Now we have 3 spaces. So what will happen if we go with QU? We have E, S, T in the increasing order. So we see that if we have to we have to go only up to QU, E, S, T. So what will happen? First we'll take E, and then first priority will come out for S only, and then the first priority will come out with T only. So this is 1. So if you see, the ranking is what? In order to reach from the beginning to QUEST, we are going through 24, we are going through 6, we are going through 6, we are going through 6. So it is somewhere 24 plus 6 plus 6 plus 6, and this is 1. So the position of QUEST in the dictionary will come out to be 37. Okay, it's like 18 plus, it's a 42. The calculation mistake, 43 it will come out to. 30, okay, 43, okay. The calculation mistake was there. So King short official, probability is already available. So probability was taken last 2 weeks ago, okay. So if you want for probability, wait, I'm helping you to give you the probability things. So So I have attached the link, okay, King Shot official. I have attached the probability playlist. It has all the topics available there, okay. So now let's move to next question. Find the sum of all 4-digit numbers without repetition of digits formed using the digits 1, 2, 3, 4, 5. So what will happen? We have 4 digits number. 1, 2, 3, 4. 4 digits number. Okay. So what will happen? Out of 5 distinct taken 4 at a time. So this is theorem 2, isn't it? So without repetition. So there will be one case where we will take only 1, 2. So how many such cases are there? If we take 5 distinct objects out of 4, okay? So for example, if we keep one fixed here, we have 2, 3, 4, one is fixed here, 2, 5, 4, one is fixed here, 2, 5, 4. Now we are here with 2, 3, 4, 2, 5, 4. We'll have 5 sheet, 4 sheet, 4 sheet 3. So we'll have 4 different cases, okay? 2, 3, 4, 2, 4, 5, 3, 4, 5, one is there, 3, 2, 5, 2, 3, 5. Normally we can say that 2, 3, 4, 2, 4, 5. Now 3, 4, 5, 2, 3, 5. Okay. So these much are the possible cases. Okay. So now what will happen? We have to find the sum. So when 1 is here, what will happen? Their arrangement is three numbers and 3 places. So their arrangement is what? 3p3, which is 3 factorial. Their arrangement is again 3p3, 3 factorial. Their arrangement is what? 3p3, 3 factorial. Their arrangement is what? 3p3, 3 factorial. So all if you see it is 6, 6, 6, 6. Okay. So when 1 is here, so 1 is what? 10 to the power 3. So 10 to the power 3 is here. What will happen? We have 2 at first position. So if this is at first position, 2 will be at first position, and their arrangement is 6. Okay. So what will happen when 2 is here? The arrangement of this is what? 2 factorial. That means if 2 is there, it is 2 factorial, 2 arrangement. When 2 is in middle, it is, if 2 is in middle, it is 3, 4. Their arrangement is what? Again 2 factorial. If 2 is at the end, their arrangement is 2 factorial. Okay. So it is 6 into 10 plus 2 is going this way. Similarly, in place of 2, if we have 3, it is going to have the same thing. So we are getting 3 into 10 square into 2, 3 into 10 to the power 1 into 2, 3 into 10 to the power 0 into 2, 4 into 10 square into 2, 4 into 10 to the power 1 into 2, 4 into 10 to the power 0 into 2. Okay, if you see, we can simply write it 6 into 10 to the power 3 plus, uh, if you see, we can take what common? We can take 2 common, which is 2 factorial common, and we can see that if we take common, it is 2 plus 3 plus 4 into 10 square, 10 to the power 1, 10 to the power 0. This is what we are getting. So this is for this one only. Now similarly going with second one, we have here 5. So can we say that it will come out to be 6 into 10 to the power 3 plus 2 factorial, 2 plus 4 plus 5, 10 square, 10 to the power 1, 10 to the power 0. Similarly for third one, 6 into 10 to the power 3, 2 factorial, 3, 4, 5. This also done in second case. This is the third case. 3, 4, 5. 10 square, 10 to the power 1, 10 to the power 0. If we go with the fourth one, 6 into 10 to the power 3, which is 2 factorial, 3 plus 2 plus 5. This is 10 square, 10 to the power 1, 10 to the power 0. Okay, Mudit, we'll go in that. Okay, we'll go. So similarly, now when there is no 2, it will be somewhere 2. So we can go with the fifth case when there is, in this place it is 2 and 1, 3, 4 is there. So we can see that we are getting 3 factorial into 2 into 10 to the power 3, which is 6 time. Okay, 6 time meaning 24. This is what we are going, this this is what we are getting, and we are getting 2 factorial. We'll get somewhere different combination like 1 plus 3 plus 4, 10 square, 10 to the power 1, 10 to the power 0, and then it will go 4 times. We can see that this got repeated 1, 2, 3, 4. So this will go 4 times, and inside this factorial, this is going, the outer part is going to be the same. We are going 1, 3, 4. We'll go 1, 1, 3, 4, 1, 5, 4. So if you say that a number is getting repeated 3 times, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 2, 3, 4, 5 is getting repeated 3 times. So we are, what now we are doing is that we are trying to generalize. Okay, first we went through complete explanation, and now we are trying to generalize. Okay, so we can see that it is not getting deleted. Okay, no problem. We can see that it is somewhere, this will come like this, like this. It is somewhere going to be 4 into 3 factorial, 2 into 10 cube plus 2 factorial into 3 times of 1 plus 3 plus 4 plus 5, 10 square, 10 to the power 1, 10 to the power 0, and the sixth one. So we'll have what? We had initially 1, now 2, now 3. So it will come out to be 4 into 3 factorial, 3 into 10 to the power 3, and here we'll get 3 factorial, 1, 2, 4, 5, 10 square, 10 to the power 1, 10 to the power 0. And the third one, 1, 2, 3 taken. Now it's a 4 time. The time for 4. So it is 4 into 3 factorial, 4 into 10 to the power 3, 3 factorial, 1 plus 2 plus 3 plus 5, 10 square, 10 power 1, 10 power 0. Now 8 1, when we are taking 5 here, it is 4 into 3 factorial, 5 to the power 10 is 10 cube, this is cube, okay, plus 3 factorial, 1 plus 2 plus 3 plus 4, this is 10 square, 10 to the power 1, 10 to the power 0. Now if you go with the summation, we are getting what? We are getting 4 factorial somewhere. If you see, it is 4 into 3. 4 factorial, 1 plus 2 plus 3 plus 4 plus 5 into 10 to the power 3 plus, if you see here, it is 3 factorial, 1 1 1 1. Okay, and here we don't have 1. That means 4 times 1, 4 times 2. So this is 4 factorial, 1 plus 2 plus 3 plus 4 plus 5 into 10 square, 10 to the power 1, 10 to the power 0. And if you go more analysis, it is somewhere 4 factorial common. So it is what? If you go analysis of this one, it is what? 4 factorial common, 1 plus 2 plus 3 plus 4 plus 5 common, and we have into 10 cube plus 10 square plus 10 to the power 1 plus 10 to the power 0. Can we say it is 4 factorial into n plus 1 by 2 into, this is 10 to the power 4 minus 1 by 10 minus 1. So this is the answer. Okay, so you can find this answer. So now if I ask you simple, what is the trick for solving this type of question? So trick is that we are given that we have to choose 4-digit number. That means we'll go with 4 factorial and sum of all the digit 1 plus 2 plus 3 plus 4 plus 5, and then we'll do 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. Okay, so this is the answer. Okay, so this is the way you have to approach the question. Let's move ahead. So this is the question we have to solve, isn't it? We have n minus 1 factorial upon n minus 1 minus 3 factorial divided by n factorial upon n minus 4 factorial, which is equal to 1 by 9. If you go further, we'll say this is n minus 4 factorial, this is n minus 4. So this and this getting cancelled, we are simply left with 1 upon n equal to 1 by 9. So n is what? 9. Simple question. 6 horses take part in a race. 6 horses take part in a race. In how many ways can these horses come in the first, second, and third place? So we have 3 chairs and 6 horses. This is the question. So we can say it is theorem 2. 6 distinct objects taken 3 at a time. If a particular horse is among the 3 winners, so we are told that 5 horse is different and 1 horse is there, already there, okay? So what will happen? We'll put 1 horse here, and now we have to keep 2 horses out of 5, isn't it? So let's see that one of the point is occupied by this one. So this will go through some different combination method, okay? We'll consider that if H1 is on the first position, now second, third position, we'll have 5P2. If H1 is at second position, so in this we can have again 5P2. Yes. And in third position, if there is H1, we can say that we have to choose only 2 4 out of 5. It is what? 5P2. If we find the sum is what? 3 into 5P2, which is 3 into 5 factorial, 5 minus 2 factorial. Okay. So this is simply 3 into 5 factorial upon 3 factorial. If you know, it is simply 60. If you calculate it, it is going to be 60, okay? Let's move ahead. Sum of the all 5-digit number formed by this one. Okay, so we already know the formula, sum of the 3 digits. That means what will happen in this type 3 digit when the numbers are formed. Mm, so we had that 5 digit. Okay, we'll have to first take few cases and then try to solve it. And note that 0 cannot be at the first position. So this is going to be exception. We have already solved such type of question. Kindly follow those guides to get this answer. How many 3-digit number are formed using this? In how many of this we have at least one digit repeated? This we have taken previously as a solved example. How many functions are defined from set A containing 5 elements to set B having 3 elements? So set A is having 5 elements. Okay. E1, E2, E3, E4, E5 is also there. Okay. And in B, we have A1, A2, A3, 3 elements. How many functions are defined? So what can happen is that a function is when this will have one x will have only one y, one x will have only one y. We cannot have two y. That means this could happen, this could happen, this could happen, and this could happen. So all can go to one. So what will happen? We'll consider that we have five places, and we have three numbers. So what can happen? We can have any number out of these three. We can have any number out of three, any number out of three, any number out of three, any number out of three. Can we say it is 3 into 3 into 3 into 3 into 3, which is 3 to the power 5. Okay, this is the first part. Second part, surjective function. How many of them are surjective? Surjective meaning one on two. That means if we have E1, E2, E3, E4, E5, and here we have A1, A2, A3. If a function is 1, that means one x will have only one y, one x will have only one y, one x will have only one y. These two are not getting any one. If we have to stay 1, this has no x, no y, this has no y, and a function is defined only when all the x should have some y. And if in order to become 1, this x will not have to have any y, that means zero number of such possible, zero possibilities. Okay, okay, let's move ahead. How many functions can be defined from A 4 element to a set B containing 5 element? Okay, so we are simply saying that A is 4 element, that means 1, 2, 3. This is 4 element. What can happen? If we have any one of 5 to this one, we can have any one out of 5 to this one, any one out of 5 to this one, any one out of 5 to this one, isn't it? So if you see, it is 5 to the power 4, which is nothing but 6 to 5. So first number done. Second, how many of these are injective? Injective meaning surjective meaning onto. Okay. Surjective meaning onto. It does not mean in one. Okay. Injective meaning one onto. Okay. Surjective meaning onto. So in this what we are trying to do is that they all will get mapped. So how many onto functions are possible? This is what we have to find. So what will happen? We'll have to take cases. If A1 is getting 2E, okay? A1 is, so it could be like A1 is getting 3E, A2 is getting 1E, A3 is getting 1E, okay? A1 is getting 2E, A2 is getting 2E, and this is getting 1E. This is the way different overlapping can happen. So what will happen if you see choosing 3 elements out of 5? So this will go to combination, okay? Permutation and combination. And this is given before combination. If you go by permutation way, it will go longer. Otherwise, it is simple, okay? So what will happen? Let's see, okay? We are trying to do it by permutation method only. So out of 5, we have to choose 3. So we will make a group, okay? Let's make a group. So 3 grouping can happen how? It will take 10 ways, okay? It will be solved. It can be solved using combination. So what we are doing, we are choosing 5C3 and 2C1 by 2, and we are arranging in 3 factorial way, and we are doing 5C2, 3C2, 1C1 by 2 factorial, and we are doing their arrangement in 3 factorial. So this will come in your upcoming topic, okay? And this is the correct answer. It will come in your upcoming topic combination. So for that, right now you consider this, and 5C3 is what? 5P3 by 3 factorial, okay? Now we have to find in this question how many injective functions are there. So injective functions, we have 4 here: A1, A2, A3, A4, and we have 5 element: E1, E2, E3, E4, E5. So we have 5 element, okay? And here we have 4 element. So it should be injective. Injective meaning 1 1. So what can happen? We'll have 5 chair, okay? We can have 5 chair. 5C4 and then 4 factorial. So we can consider that we have 5%, we have to select 4 at a time. 5% selected 4 at a time, which is 5P4. So this is the answer, which is 5 factorial. 5 minus 4, which is 5 factorial. Okay, let's move ahead. In how many ways 5% can enter a auditorium having 5 entries? So if such type of question comes, we have 5% that will enter 5 auditorium. Four gates, that they have 4 gate. G1, G2, G3, G4. And we have P1, P2, P3, P4, P5. So we have 5%, 4 gates. So we have to enter through this gate. So what will happen? We will simply divide, okay? We can tell that all person, okay, all person will go through, all person will go through only one gate. So what will happen? This is simple case, okay? This is 1, 2, 3, 4, 5%. So this person can enter through any one of the 4 gate. This person can enter any one of the 4 gate. This person can enter from any one of the 4 gate. This person can enter from any one of the 4 gate. This person can enter from any one of the 4 gate, which is 4 to the power 5, which is 2 to the power 10, which is 10, 0, 2, 4. Okay, this is the simple way to solve it. It's the sum of the digit which can be used. Okay, so we already solved this type of question. 8 cards are shuffled. In how many ways 2 card will form a pair of twin? Top 2 card will form a pair of twin. Okay, so this is pair of twins, so I chose it. So pair of twin prime. So pair of twin prime meaning P and Q are said to be pairs of twin prime if they are consecutive and both are prime. Can't it be? Pairs of twin prime, okay? Anyone tell me what is pair of twin prime? Okay, so twin prime will come out to be the numbers are said to be twin prime if they are consecutive consecutive with the difference of 2. They are consecutive with the difference of 2, and they are themselves. Example, if we have 1, 1 is not prime, 2, 2 is prime. If we add 2 plus 2, which is 4, 4 is not prime. So 3, 3 is prime. If we add 3 plus 2, I am getting 5. This is prime. 5, 5 is prime. 5 plus 2, 7, 7 is prime. So here we get 3 comma 5 as prime, 5 comma 7 as prime. Now we have what? 7. 7 is prime. 7 plus 2, 9. 9 is not prime. And our limit is only up to 7, 8. Okay. So 2 cards are shuffled. The top two meaning like 8 numbers are there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So what will happen? First two should be twin prime. So twin prime pairs are what? 3, 5, 7, 5, 7. Okay. So if we get 4, 3, 5. So for 3, 5, we have only two places. So two distinct number, two places. So n distinct number, n places. Find the total arrangement. This is what? 2p2, which is 2 factorial. Similarly, for this one, which is 2p2, which is 2 factorial. Okay. Now, when we have 3 and 5 here, we are left with how much numbers? We are left with 6 numbers. So 6 numbers are all different, 6 distinct number, and 6 places. So total permutation is what? 6p6, which is 6 factorial. So can we say it is 2 factorial into 6 factorial? And similarly for 5 and 2 we can have 6 factorial again. So if we say total sum is what? 2 into 2 factorial, 6 factorial. This is the answer. 2 factorial into 6 factorial. This is the answer. 720 into 4. 2880 is the answer. Let's move ahead. If all the letters of Q are arranged, then the dictionary word. We already did it. The sum of all 4 digits which can be formed, this we already solved it. We already solved this. The number of 6-digit number which ends with 21 without repetition of digit. So this already we did it, okay, but it is simple, so we are trying to make attempt. 1, 2, 3, 4, 5, 6, 7. We have already 1, 2, 3, 4, 5, 6, 7. No, 6 digit. It is 6, okay. So we have 2 1 here, and it should be distinct. That means total digit in our pocket is what? 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 and 1 already taken here. Now at this position, how many options are available with us? 0, 3, 4, 5, 6, 7, 8, 9. So if we put 0, it is not going to be called as a 6-digit number. So 0 is not here. So we have only 3, 3, 6, 7. 7 option. Now in this place, out of 7 we choose for example 3. Now we are left with how much? 3, 3, 6. And at this place we can put 0 also. So we have again 7 option. And then when one of the number is chosen, now we have how much? 3, 3, 6, 6 option. Now one of the number is chosen, we have 5 option. So this is simply 7 into 6 into 5. This is the answer. Let's move ahead. 4 locks are there, maximum unsuccessful attempt. So we have 4 dials, okay, and we have a now digit from 0 to 9. What can happen here? We can have multiple 10 possibilities, 10 possibilities, 10 possibilities, and 10 possibilities. So if you see, total possibilities are what? 10 into 10 into 10 into 10 equal to 10 to the power 4. Okay, okay. So this is total possible. Out of that, one will be success. So total unsuccessful attempts. So what will happen? Out of 10 to the power 4, one will be successful, one is correct. So total unsuccessful is what? 9999. That's all. Solve this as a homework. Solve this as a homework. Solve this as a homework. Pause the video, solve this question. If you don't face problem, you ask me. Solve this as a homework. 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 Solve this. So I am trying to take this question. 2n factorial upon 2n minus n factorial, which is 2n factorial upon n factorial. If we see, it is 2n. So 2n minus 1, 2n minus 2, it will go up to 3, 2, 1, and we are left with n factorial. If you try to take 2 out and 2 out, it is what? N minus 1, n minus 2, dot 1, 2, 1. This is 2 to the power n will come out, and we are left with what? We are left with 2n minus 1, 2n minus 3, dot up to 3 into 1. And in denominator we have what? N factorial. If you see this term is nothing but n factorial. So this term cancels. So we are left with 2 to the power n, 1, 3, 5, 7, dot 2n minus 1. So B is correct. B is correct. Okay, now if you multiply, so this will give us option B. If we multiply 2 to this one, Can we say it is 2 into 6 into 10 into 14 dot 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 4n minus 2? So this is option C. Okay. Now further, if you want to go with this, so if you see in this 1, 2, 3 up to n is getting cancelled. 1, 2, 3 up to n is getting, we are left with what? N plus 1, n plus 2, dot 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 2n. So this is option A. Option D. Option D, for now if you want, it is n factorial. 2n is what? 2n factorial upon n factorial n factorial. So n factorial cancel. This is simply 2np n. Okay. So this is option D. So A, B, C, D correct. This solve as a homework. This solve as a homework. Now we are on lecture 3. We are on lecture 3. I am giving you 5 minutes of time. If you have to get any break or anything, come after 1 minute. Well, only just 1 minute, okay? After 1 minute, come back. Hi. हाँ? क्या? दाल की तरह दो। अपना जूता दे दीजिएगा ऐसा हो। कल तक मैं सुत पाएगा 8 बजे तक? हाँ? नहीं, कल रात तक वो वाला जूता पहन लेंगे। फटेगा तटेगा ना, नया जूता है। हाँ? कपड़ा सूखे दे देंगे। सबसे गुड रैम पार्टनर। Okay. So now it's the time for combination. Okay. So while studying combination, combination is total number of way of choosing. If we are given an element and we want to choose only 5. So this is what combination meaning. Okay, if you want, then I want to say that combination, it is selection of selection of one or more things out of n things which may be alike or different, taken some or all at a time. So we are told that we have n things. They may be similar type things or they may be different things. If we want to take, if we want to select some things or all things, so this is what combination meaning. Like if I tell you I have 5 different objects. Okay, if I have 5 different objects, okay, I have one doubt. I have commented it on one of your video. Please check. Okay, I will check. Okay. So what happened? 5 different objects are there, and we have to select three. We have to select 3 objects. Okay, three selection has to be there. Okay. So how will we do? We'll do simply by saying 5C3. So what is this representation? This meaning 5 factorial upon 5 factorial upon 5 minus 3 factorial into 3 factorial. This is what? This meaning 5p 3 upon 3 factorial. Okay. This is 5p3 upon 3 factorial. So this is the way we select 3 things. Okay. And if you get the value, this is okay. We got the answer. That's all. So the answer would be what? Calculate it. If you calculate, you will get the answer. It is 5 factorial upon 2 factorial, 3 factorial. It is 5, 4, 3, 2, 1 upon 2 into 3 into 2, which is nothing but 10. Okay. So if you have any doubt, connect me on my WhatsApp. You send the question, I will send you the solution. Okay, so you can do that. So moving ahead, theorem 3. So theorem 3 meaning the theorem that we discussed right now. Number of this is theorem 3, yes. Number of combination. Number of combination or selection. We'll call it selection. Combination will make you in some doubt. Number of selection of and distinct things, okay, taken are at a time. Okay, so this is represented as NCR, which is nothing but n into r factorial. This is it. Okay, moving ahead. Moving ahead, we have theorem 4. Number of combinations. It is saying that if we have number of selection of number of selection of okay, number of selection of R object out of n different things given p particular elements are to be included. Number of selection of R objects out of n different things given p particular elements are to be included. Okay, that means we have n objects. Okay, we have to select R objects in which p objects has to be there. P objects will have to be there. Okay, so what will happen in order to get in order to make R object, what will happen in n will minus p, okay, and in R will minus p. So out of n minus p we have to select R minus p. It is something that, so it is what if you try to mix them, out of n minus p objects, R minus p objects need to be chosen. Can we say this as n minus p c R minus p? Can we see this? number of selection of R objects out of n different things given p particular elements are to be included. Okay, let's move ahead. Theorem 5. So this question will help us to get everything. Okay, first we are going through theorem 5. Okay, now it is that number of selection of R objects out of given and distinct objects given p particular objects need to be excluded. So we have n objects. We have to select R objects in which P objects excluded. So tell me what will be the thing. So in N we'll minus P and we'll choose R out of that. Can we do that? This is N minus P CR. This is the answer. Got it? Okay. Moving ahead. There are 15 players for a cricket match. How many ways 11 can be selected? So we can say that out of 15, choose 11. This is the answer. Second one, in how many ways 11 can be selected, including one player? So we are given 15 players. We are told that in 15, one has to be included always. So we are left with 14. So that means what? If one is included, so out of 14 we will have to choose 10 to make it 11, isn't it? So can we see that? Say that it is the answer is 14C10. Yes. Third one, in how many ways 11 player can be selected excluding two players? So we have 15 players. We want to exclude 2. After excluding 2, we are left with 13 players. So from 13 we have to select 11. That means it is what? 13C11. That's the answer. That's the answer. Move ahead. Now we have this thing. Okay. So what can happen if you know binomial theorem? We can say that 49C 3R minus 2 could be written as 49C 49 minus 3R minus 2, which could be written as 49C, which is given as 49C 2R plus 1, which could be written as 49C 49 minus 2R plus 1. So what will happen? We can say that 3R minus 2 is equal to 2R plus 1. This equal to this. Second, we can say that 3R minus 2 is equal to, okay, is equal to, this is what? 48 minus 2R. Okay, so this with this and this. Okay, and this with this. 49 minus 2 is 51 minus 3R is equal to 2R plus 1, and the fourth one 51 minus 3R is equal to 48 minus 2R. If you solve from here, we are going to get R equal to 3. If you solve here, we are going to get 5R equal to 50, R equal to 10. If you solve here, we are going to get R equal to 10. If you solve here, we are going to get R equal to 3. So our answer is 3 and 10. Yes, got it. R is 3, R is 10. A regular polygon has 20 sides. How many triangles could be formed, could be drawn by using the vertices, but not using sides? So there should not be a size used. That means if a polygon is somewhere like this, 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 okay, it should not use its side. Okay, we'll say that total number of points on polygon, total number of points, that means total number of vertices on polygon is equal to 20. Okay, so if we'll choose 3 points to form a triangle, it could be 20C3. Okay. Now what will happen? So we'll choose one of the side. For example, we'll choose this side. So if we choose this side, we'll not choose this one and this one. So we are left with how much points? 4 points gone. We are left with 16 point. So we'll choose, so 3 points given one side is common. So what will happen? Choosing one side is what? 20C1. Okay. So now we choose, for example, this side. So 4 points are eliminated. So out of 16 point, we have to choose one. So this is the total number of points, total number of triangle formed given one side is common. So 3 points chosen given two side is common. So for example, this and this side is common. Okay. So we can have how much possibilities? One possibility, two possibility. So if we have like 1, 2, 3, 4, 5, 6. So if we take one possibility, two possibility, three possibility, four possibility, and five possibility. If it is six, we have five possibilities. So if we have 20 sides, so we have 19 possibility. So 19 C1. And now if we chose this side, that is 1, 2, 3, 4 and 5 points are eliminated. So we have to choose 15C1. Yes, so this is the way we can choose two common side with a point different from, we can choose, so 3 points given two sides common. This is the total number of selection. So how many triangles can be formed using no sides are common? So total numbers of triangle with with no common sides, which is 20C3 minus 20 into 16, 320 minus 19 into 15. So this is going to give you the answer. Solve it and get it. Okay, let's move ahead. 15 persons are sitting in a row. In how many ways we can select three of them if adjacent persons are not selected? So 15 persons are there. We have 15 persons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we don't care this. Okay. So what will happen? So we'll have what? We'll choose 15C3. Okay, we can't choose 15C3. 15C3 is total number of ways. total selection is 15C3. We chose 15 people out of 3. We chose 3 people out of 15. Now we have to choose in such a way that they are not consecutive. This is our outcome. That need to be our outcome. So for that, we'll take 3 people are adjacent. So we consider that first 3 people are adjacent. Then what is the different way? So it is what? 1, 2, 3, 4. So we are left with what? This is 1, 2. So 15 minus 2 is 13. We get 13 ways. Because this is one way, so 2 is eliminated and we are counting all. That means we are left with 13 numbers here. So we have 13 ways. Now this is what? 2 people are adjacent. So out of 15, 2 people are adjacent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2 people are adjacent. For example, we took this one. Now we have to choose what? We have to not choose this one and we have to choose the rest one. That means out of 15, 3 people gone. We are left with 12. So we can say 12C1. Now when we move here, when we move here, we'll eliminate this and this. We are left with what? 11C1 and it will keep moving, okay? So how many such type of things are happening? If you see, this is 1, this is 2. So we'll be having total we'll be having only up to this much. Okay, this much is what? Uh, 1, 2, 3, 4, 5 up to this much. What can we say? This is 1, this is 2, this is 3. Okay, it will happen like that. 5 gone. So here we have only up to 14. So what is happening if we are left with this one? Okay, we are getting 11C1. So 11C1 is going to happen how much time? That I am trying to see. When we shift this way, we have 11C1. We shift this way, we are 11C1. So we reach up to here. So up to here, this is going to be how much? 3, 1, 2. So this is 14, yes. Wait. This is 1. We are finding some generalized. 1, 2, 3, 4. Mm, we will have 11, such 11 counting, okay? So we'll have 11 counting plus when it is at the end we have 12C1. So 11, 12, 13. Okay, 13 countings are there. So this is the total number of ways when they are sitting like they are consecutive. Okay, and we have to select only 3 people. So total numbers of ways in which they are not adjacent. Total number of ways in which they are Note adjacent. It is 15C3 minus 13 minus 12 minus 121 minus 12. So this is the way. Calculate it. Calculate it. Let's move ahead. In how many ways we can select four letters from the letters of the word Mississippi? In how many ways we can select four letters from the word Mississippi? So what will happen in Mississippi? We'll first find the words. We have 1M, we have 4I, we have 4S, we have 2P. Okay, so we have to select four words. Out of this, we have to select four words. Okay, so in this, what will happen? If all letters, all letters of all letters are distinct, if all letters are distinct, then one letter will come from here, one letter will come from here, one from here, one from here. So four distinct letter and four chosen. We can say 4C4. Okay. Now, mm, now one is this. We can have this is what all distinct. One, two, three, four. All distinct. Now second case is one is single, and one is double. Okay. One single, one single, and one is two type. Okay, this is the case 2. This is case 1, this is case 2. So what will happen? For a letter to have two times, it could be selected only from this 3. So we can say it is 3C1, and if one is chosen, we are left with this. So we can say 3C2. Isn't it? Okay. So this is the way we can choose it. And now third case is this is double, this is double. So what can happen? We can choose 3C2. One case could be we have one single and three numbers, three same. Okay, one different, three same. One different, two same. Two same, two same. One different, three same. So one different, three same. For three same, we will be choosing 2C1. And now if this is chosen by some luck, if this is chosen, we are left with 1, 2, 3. So out of 3, we have to choose one. Now fifth one. Okay. So now, have we taken all the criteria? We can have one different, two different, three different, meaning four different, and now we have all same, four same. That means out of two, we have to choose one. And the different ways are what? We'll add all. So 4C4 is 1, 3C1, 3C2 is 9, 3C2 is 3, this is 6, this is 2. This is 9 and 18, 21. Okay. So there are 21 different methods and this is correct. Okay. Three different, meaning four different. And now we have all same, four same. That means out of two, we have to choose one. And the different ways are what? We'll add all. So 4C4 is 1. Okay, now let's move ahead. In how many ways 7 persons can be selected from among 5 Indian, 4 British, 2 Chinese? So we have to form a letter. So it's like 7 persons. 7 persons should be selected. So 7 persons should be selected. 1, 2, 3, 4, 5, 6. So 7 persons should be selected. At least 2 are to be selected from each country. That means 2 Indian, 2 British, 2 Chinese are already they have to be there. Okay. So this is 6, and we have one unknown. We don't know from which country will it be selected. So what will happen if we select one Indian, 2 Indian? So can we say selection of 2 Indian, 2 British, 2 Chinese, and one unknown? Okay. So what will happen in order to mitigate the doubt? We'll consider that we are choosing 3 Indians, 2 British, 2 Chinese. Can we say it is 5C3, 4C2, 2C2? Second, 2 Indian, 2 Indian, 3 British, 2 Chinese. 5C2, 4C3, 2C2. Okay. So total ways are what? We'll add them. We are getting 5C3. So let's 5C3, 4C2, 2C2 is 1 only. 5C2, 4C3 is 4, and this is 1. We'll calculate this. This is 5 factorial upon 3 factorial, 2 factorial. This is 4 factorial, 2 factorial, 2 factorial. This is 5 factorial, 2 factorial, 3 factorial, 4. If you solve it, this is 5 factorial is 120 upon 12, which is 10. This is 6. Okay. And this is 10. into 4. So the answer is somewhere coming out to be 100. So we have 100 ways of selection. Okay, so let's move ahead. Find a number of different 7-digit number that can be written using the word 1, 2, 3 under the condition that 7-digit numbers. Okay, so we have to write a 7 digit numbers that can be written using only 3 digits 1, 2 and 3 under the condition that the digit 2 occurs exactly twice in each number. So 2 has to be exactly 2. 1, 2, we have 7 place. Okay, let's make this box. 1, 2, 3, 4, 5, 6. So we have 7. We have to have two twos. Twos are same. Okay. And if twos are same, so we are left with five place. If twos are same, for example, we are left with 5 places. So in 5 place, what can happen? All threes, one, one threes, one threes, two threes, three threes, four threes, five threes, no threes. Okay. So what will happen? See, so what will happen? See, when all threes are there, okay, that means 5 threes. So 0, 1, 2, 3, 4, 5, all 5 are there. So when there is no zero, no threes, that means we have all fours, all twos, not all twos, all ones. So 2 is exactly 1, yes, all ones. 4 times ones, no, 5 3. So 0 times ones, 1 times ones, 2 times ones, 3 times ones, 4 times ones. Okay. So now what will happen when we have two twos? It is the same. So if this is the case, the arrangement is what? 7 factorial upon. If it is same, 3 is 1 time, so it is 1 factorial. 1 is 4 times, so 4 factorial. 2 is 2 times, so 2 factorial. Similarly, we are going with this 7 factorial. 2 is 2 times, 3 is 2 times, and 1 is 3 times. 7 factorial. Now we did this one. Now we have this one. This is 2, 3, 2. 2, 3, 2. Now going with the next one. It is 2, 4, 1. This is what? 250. This is what? 205. If you solve it, you will get the answer. That's all, okay? So this question we'll do later. In how many ways six boys and six girls can sit in a round table so that girl and boy seat alternate. So what will happen? Okay, I'm taking this question. We have here boys 1, boys 2, boys 3, boys 3, boys 4, boys 5, boys 6. Okay, and we have to seat alternate. That means if you see there is one gap, two gap, three gap, four gap, five gap, six gap. That means we have to fill G1, G2, G3, G4, G5, G6. So from circular permutation, if we are doing permutation of a boys, okay, then it is going to be 6 minus 1 factorial, and the permutation of girls is going to be 6 factorial. That means it is 5 factorial, 6 factorial. So this question we'll do in circular permutation. Move ahead. 4 persons can occupy 10 chairs in a row if no two sit on adjacent chair. If no two sit on adjacent chair, then what? So 10 chairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of ways of selecting 4 chairs out of 10 chairs. It is what? 10C4. And we are given that they should not be adjacent. That means if two are adjacent, we have done such type of question. Two are adjacent. So if two are adjacent, we'll take this one. The third one should not be this one. We'll go with this one. 1, 2, 3 like this. So 3 gone. We are left with 7. So we'll choose 7C1. Okay. And if it moves in this way, we have 4 people gone. 1, 2, 3, 4. This also gone. We are left with 61, isn't it? And this is 1. In 3, it is 1. We have to reach only up to this much, okay? Okay, if you count 1, 2, 3, 4, 5, 6, 7. Okay, so it will go 7. So 6C into 7 plus last one. When we are on the last, we have again one option of 7C1. 3 are adjacent. So 3 are adjacent. That means we will not have these people. So 3 are adjacent. So we have 1, 2. That is 15 minus 2, which is 13. 13C1. So total ways in which 4 persons Okay, okay. Four chair we selected. Okay, we selected two persons here. Okay, wait. We have to choose take like four. Okay, we have something wrong here. I was taking only 3% sitting together. Okay, okay, wait. So four chairs out of 10 chairs. Okay, so 10C4 is the way of choosing. Now four people will have to choose. So what will happen if we select this way? One, four, three, four people are there. Yes. Now 10 chairs should be there. We'll have to take multiple cases. Okay. In such type of question, we'll have to take multiple cases. So we should be going with the cases. Okay. What will happen? One, two. If we put one chair in between, one, two, three, four, five. Five chairs is going to get occupied. We are left with five, four, nine chairs are going to be occupied. They will sit on the fourth chair, and the gap is one, two, three, four, five. That means we have six chairs left. Six chairs left and four occupied. Four occupied. Yes. So what will happen if you group it in this form? Two chairs together, one chair, one chair, one chair, one chair. Yes. So this is the person. One, two, three, four. So we will what we'll do is that we'll put two chair here, one chair here. Similarly, one chair, and one chair. Yes, this is the case. The arrangement of these chairs are what? 4 factorial by 2 factorial. This is 5 factorial, and this chair are same 4 factorial. So this could be done in 4 different ways, and the arrangement of these persons could be done into 4p4, which is 4 factorial. Okay, got it? Now, when this person shift here, we are left with two chair, one chair, one chair, and then we have three, four, two chair. Okay. So in this case, the arrangement will be 5 factorial. These two chair are same. So 2 factorial, and their arrangement is 4 factorial. 4p4, which is 4 factorial. Okay. Got it? And one case will come when here one, two, three, four are there. So we can have two chair, one chair, one chair, one chair, and one chair. Okay. So this will come out to be 5 factorial, 2 factorial, 2 chair. No, what happened? There is no chair here. Okay. So one chair, two chair, 2 to your 4, 4, 6. 2 factorial, 2 factorial into 4 factorial. One case will come out that here is 3 chair, here is 1 chair, here is 1 chair. So this is what? 1, 2, 3, 4. It was 4 factorial, okay? It was 4 factorial. We have only 1, 2, 3, 4, isn't it? 4 factorial. Here we have 5. Here we will be having 3 factorial upon 2 factorial into 4 factorial. And now one case is that this. We have 2 chair, 2 chair. When there is no chair, there will have to be 2, 2, 2. Okay, 2 chair. It is only 3 factorial. Okay, it is the same. So I was trying to say the same 2 factorial, 2 chair. So the total number of cases are what? 5 factorial plus 6 into 4 factorial plus 6 into 4 factorial plus 4 factorial. This is overall 120, 144 into 2, and this is 24. So we are normally getting 120 plus 288 plus 24, which is 144 plus this. So 144 into 3. This is the answer somewhere coming, okay? So we did not go through this way, we went through this way by taking multiple cases because we were finding that. Okay, so this is overall the cases. Okay, let's move ahead. Number of ways 3 letters of the word can be selected. So we already did in Mississippi type of question. So this we did already. This is the question I wanted to do. Okay, this is the good type of question. Find the number of ways of selecting sets B and set C. So B is subset of A, C is subset of A, CA. So what can happen? Out of and B can have no element. So B can have no element. Okay, B can have no element. B can have one element. B can have two element. B can have three element. B can have all element. Similarly, in case of A can have no element. A can have one element. A can have two element. A can have all element. Okay. So if B and this is C, okay. If B and C is happening parallelly, that means if we have NC0, if B has no element, A can have NC0, NC1 up to NCN. If it has one element, it can again have no element, one element up to n element. Okay, and it will keep on going like NC2, again NC0, dot dot dot. So it will go up to NCN, NC0, NC1, dot dot dot, NCN. So if you find, it is simply 2 to the power n into 2 to the power n, which is NC0 plus NC1 plus NC2, dot dot dot, NCN into NC0, NC1, dot dot dot, NCN. Okay, so this is 2 to the power 2n, which is 4 to the power n. Got it? Next, moving, we have some specific ordered pair of B and C such that B intersection C is phi. Okay, so second is ordered pair of B and C. Ordered pair of B and C. That means if B has ordered pair of B and C, that means we are taking B and C. If B is phi and C is, if B is phi and C is 1, then it is not equal to 1 and phi because they are ordered. Their order matters. Okay, so this is not equal. So what will happen in B? We'll choose no element. Then what will happen in C? We are left with all element. Okay, in B elements are phi. Then for C we have all element from 1 2 up to n. So C can have no element or one element or two element or all element. Yes. Second case, when B has one element, for example 1 or any one of the 1, any one of the n, which is NC1, then what will happen? We are left, for C we are left with only n minus 1 element. So in that we can have no element, we can have one element, we can have two element, we can have all element out of NC n minus 1. Similarly, now this time we have any two element. So what will happen? This will go NC2 and now we are left with n minus 2 element. So we can have no element, one element, dot dot dot, all element. So this will go up to when NCN, and this is no, this is with no element. Okay, this means it has NCN, it has no element. That is what, uh, we are left with 0 C 0, or we can say it is 1. Okay, it is 5. So what will happen if you see, it is simply NC0 2 to the power n, NC1 2 to the power n minus 1, NC2 2 to the power n minus 2, dot dot dot, NCN, this is what, 2 to the power 0. Yes. So overall if you see, it is the expansion of 1 plus 2 to the power n, which is 3 to the power n. So I think you got it. So now second, unordered pair of B and C such that B intersection C is phi. Okay, what will happen? Now, in ordered pair, in unordered pair, If it is no element and it has some element, okay, if this is the group, then it will be equal to one element and no element. I mean, they were distinct, isn't it? Phi 1 is not equal to 1 5, but here phi 1 will be equal to 1 5. So this is the difference between ordered and unordered pair, okay? So now what will happen? So there is some point like we started going from here. If you understood this question, it is something we kept on going from NC0 2 to the power n up to NC0 NC n by 2 minus 1 2 to the power n by 2 plus 1. We went up to there. After this, when we move ahead, we are going to have NC n by 2 2 to the power n by 2. And after this, whatever comes, it is the repetition of this one. So we know that this complete sum is equal to what? 3 to the power n, and if this part is taken as x, the part after this is again x. So we can say 2x plus NC n by 2. NC n by 2 is what? Which is NC n by 2 is what? We have to find that value. Otherwise, we'll write it simply as 2 NC n by 2, 2 to the power n by 2 equal to 3 to the power n. We have to find, no, we have to find x plus this thing. Okay, x plus this thing. We have to include this. We have to find x plus this. So we can say x plus nc n by 2, 2 to the power n by 2 is equal to 3 to the power n plus nc n by 2, 2 to the power n by 2 upon 2, but divided by 2. Okay, so this is the final answer we are going to get. Okay, now going to this one, ordered pair of B and C such that B union C is A. So that means if B has no element, C has all element. So I am taking fourth question here. Okay, B union C is A and B intersection C is 5. That means if B has no element, okay, if B has no element, C has all. If B has 1, it has n minus 1. That means we will choose NC0, the raised one is of C, NC1, the raised one is of C, NC2, the raised one with C. So it will go up to NCn, which is simply 2 to the power n. Okay, 2 to the power n. Question number 5th. We have to check unordered pair. Yes. So for unordered pair, we'll go from NC0, NC1 up to NCn by 2 minus 1 plus NCn by 2, and after that we are going to have this term repetition after this, which is equal to what? 2 to the power n, and this will become 2 time of x, 2 time of this plus this is this. Now we have to find x plus nc n by 2, which is what? 2 to the power n plus nc n by 2 by 2. So this is the total number of unordered pair. Now sixth one, we are going with sixth one. Okay, sixth one, ordered pair of B and C such that B intersection C is singleton. Okay, so if B has one element, C can have that element or more than that element. Yes, so if B has 1, C can have 1, C should be having 1. Along with that, so B has NC1. Now C will have one element, that this element, and other than that, we are left with n minus 1 element. So C will be having n minus 1 C0, n minus 1 C1, dot dot dot, n minus 1 Cn minus 1. Now B has NC2 element. So that 2 element will be with C definitely, and it will have more than that n minus 2 C0, n minus 2 C1 plus dot 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 n minus 2 Cn minus 2. So it will go move ahead, and finally we'll have NCn, and it has all elements. So you can say that we are left with 0, 0 C0. So if you solve this further, simplify sixth one. So we are simplifying this as NC1 2 to the power n minus 1, 2 to the power n minus 2. So this is going further. We have NCn 2 to the power 0. Okay. So we have only one term missing, which is NC0 2 to the power n. So if we add 2 to the power n, we will have to, if we solve it, it is what? 3 to the power n minus 2 to the power n. Okay, so this is the answer. So answer of this is 3 to the power n minus 2 to the power n. Moving ahead, solve it as a homework. Solve it as a homework. No, I will take this question as a example. 10 speakers are there. 10 speakers are there, okay? So in a conference, 10 speakers are there. S1 wants to speak before S2. S2 want to speak. S1 wants to speak before S2. Okay? Okay. And S2 wants to speak after S3. That means S1, S3, S2. One case could be this one. Second case could be second case could be S3, S1, S2. So what will happen? We have 10 speakers. Okay. So we'll consider there are three speakers. Okay. There are three speakers. So we are left with only two speakers. We are left with only seven speakers. So one, two, three, four, five, six, seven. We have seven speakers. And now we have three speakers. So we have one, two, three, four, five, six, seven, eight gaps. We have eight gaps. So what will happen? We will choose three gaps out of this 8C3. Okay, and in this S2 is fixed. If you see S2 is fixed, there is arrangement only among this. So two people, two places, 2P2, which is 2 factorial, and then arrangement of 7 people is 7 factorial. So this is the answer for this question. 8 chairs are numbered. 2 women, 3 men wish to occupy one chair each. First, the women choose the chair amongst the chair marked 1 to 3. Okay. Then the men select the chair. So we are told in this question that we are 8 chair. 1, 2, 3, 4, 5, 6, 7, 8. 8 chair. One, it is numbered from 1, 2, 3, 4, 5, 6, 7, 8. In this fourth chair, okay, this woman will choose the seat. So the choosing seat is what? 4C2. She chose this or this, okay. Now we have three men. So three men will be left with this. So out of six, he will choose three. So this is the total way of selecting the position. And their arrangement. Now what will happen? Now this is the total way of selection. So total arrangement is 4C2 2 factorial, in which the women will arrange themselves. Okay. And 6C3 and 3 factorial for man's arrangement. Okay. So we can see that it is 4P2 and 6P3. Yes, this is the answer. Let's move ahead. Not all the girls sit side by side. So this question, take it as a homework. 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 And I think we have already selected such type of question. Or take it as a homework. 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 Now we are on alike objects. Okay. Moving to lecture 4, we will have 15 5-minute break. We'll return at, we'll keep it 10-minute break, okay? We'll return at 15, ये 15 हो रहा है, 5:30, 30 p.m. back, okay? भैया खाइए क्या? खाइए क्या? नहीं मैं खा लिया, बहुत कम खाए। हाँ बहुत कम खाए। हाँ खाने बात अभी जब जितना लेना है ये जितना क्या आपके बच जाए, एक आदमी के बच जाएगा। ये ना क्या टमाटर चटनी नहीं ना, प्लेन प्लेन ये रखा खाना अच्छा लगे, खाने के लिए ठीक है, लेकिन प्लेन प्लेन लग रहा था। टमाटर या धनिया पत्ता की चटनी होती है, दाल सब खा रहे हैं आप। ट्वेल्थ बाकी है आपका? क्लास हो गया बाकी? क्या कोई काम था? नहीं जाएंगे जाएंगे 8 बजे के लगभग, 25 तारीख। नहीं सर हम्म। अभी सैलरी आया बोलता है, भाई नहीं आया, मतलब भाई देखना 31 को लेता है 30 को लेता है। हम लोग की लास्ट वर्किंग डे इस दिसंबर का लास्ट वर्किंग डे पड़ रहा है 31 तारीख, 31 दिसंबर तो संडे को आ जाते हैं ना। संडे में है ना लास्ट वर्किंग डे 31 दिसंबर है। लेकिन जो हम लोग का जो महीना का जो लास्ट दिन होता है ना काम करने का, उस दिन सुबह आता है। 4 दिन पहले बैंक को ये लोग ये कर देता है, जो बैंक के थ्रू आता है हम लोग का। हम लोग का पहली बात है कि हम लोग कंपनी का क्या है ना कि ऑल ओवर वर्ल्ड के लिए एक कंपनी है वो करता है। इंडिया क्या है कि इंडिया का कानून अलग है, प्रत्येक देश का कानून अलग है। नहीं देखिए ग्लोबल पेरोल चलता है, वो फिलीपींस का हो या इधर का हो, लेकिन इंडिया के लिए लोग अलग से पेरोल है, क्योंकि अकॉर्डिंग टू इंडियन लॉ इंडियन कंपनीज में, इंडियन या फॉरेन कंपनीज में इंडियन कंपनी ही पेरोल करेगा, फॉरेन कंपनी नहीं। ये कंपनी इंडिया के नाम पर रजिस्टर्ड हुई होगी। इंडिया, इंडिया में है, इसका ऑफिस है हैदराबाद में, इसका मेन ऑफिस है, ठीक है, मेरा कंपनी का फैक्सेट का। और इसमें क्या है कि मेन ऑफिस इसका यहाँ पर, और इसमें क्या है कि जो सैलरी वाला है सरकार के साथ जो भी फाइनेंस स्ट्रक्चर होगा इंडिया में, ठीक है, सैलरी देने वाला वो इंडियन कंपनी ही करेगा। अगर फॉरेन कंपनी होगा तब भी उसको इंडियन कंपनी से ये करना पड़ेगा, एग्रीमेंट करना पड़ेगा पेरोल के लिए। तो पेरोल की अलग कंपनी है, बैंक हम लोग आईसीआई, उसने हमारा बैंक में चेंज होगा, बैंक तो अमेरिका होगा या कौन सा होगा, लोग बात से हम लोग फिर पैसा काटेगा, डॉलर में पैसा काटेगा फिर। हाँ बताइए। उतना लेकिन साफ नहीं हुआ आपका ना, हल्का साफ हुआ, ये तो रही क्या किया हटा और ना, हटा नहीं, मतलब कि जो वो शूज है ना नाला कुछ पे देखिए हो गया, लेकिन गंदा गंदा साफ नहीं है। आपका कैसे साफ हो जाता है? मेरा तो ब्लू है ना, उजला वाले में प्रॉब्लम होता है, उनको है ना ऐसे प्रॉब्लम होगा तो उजला, क्योंकि गंदा इसमें है ही नहीं। शुरुआत में शुरुआत देखिए ये थोड़ा आपका ज्यादा साफ हुआ है, यही हाँ है ना, ये वीक नहीं हुआ। मम्मी बोली उजला कहीं दो तो प्रॉब्लम हो जाएगा ना, वाइट वाला में ना। हाँ वाइट वाला में होता है, और उसमें जूता कोई था ही नहीं उजला के अलावा। कल आपका फिर ऑफिस जाना होगा, 30 31 पूरा ऑफिस छुट्टी है, 31 कल मेरा सुबह में का 5 बजे उसके बाद फिर आपका 31 को फ्री हो जाएगा, तो फिर वही क्लास का 10 बजे तक। 31 को जाने की मैंने बता दी, छुट्टी लीजिएगा कुछ कल जाके पूछे मेन ऑफिस जाना। हाँ पहले आपको उसका भी करना होगा ना कि आपको आप एमपी जाएंगे कि नहीं जाएंगे, ये लोग बोले करने लगे टिकट बुक करेगा लोग, चैतन्य वाले को कॉल क्यों ना उठाए। हम आप चैतन्य वाला समझ रहे हैं, हम पूछ रहे हैं आपको एमपी जाना है कि नहीं। अगर आप 2 के बाद इस हफ्ते में सोच रहे एग्जाम देने के लिए, तो आपको 2 दिन पहले बोलना होगा, तब वो लोग करेगा टिकट करेगा। सर हमको करना है पैसा पे कर, मुझे फिर आप तत्काल मिल लीजिएगा। हम देखिए 2 तारीख का टिकट अवेलेबल है, 2 तारीख का टिकट अवेलेबल है, ठीक है। आप 1 तारीख को टिकट कीजिएगा तो तत्काल में गिनती में आएगा। नहीं कल जाके कल कल तक में ना हम फाइनलाइज कर देंगे। अगर ये कल 30 तारीख है, आपको टिकट करना भी उसी से करना है, आपको 30 से 31 को ही टिकट करना होगा। 31 एक को कहाँ से, एक को तो आपका ये खुल जाएगा, तत्काल खुल जाएगा, लेकिन तो अगर आपका टिकट कल तक कर देंगे। हाँ अब 31 को भी कर सकते हैं, एक दिन पहले तत्काल हो जाता है। जैसे घर को जाना था रांची, लेकिन मेरा टिकट नहीं मिल रहा, तो उसकी जगह कल रांची आपको कौन तारीख है, 29 तारीख है ना, हमको 31 को जाना रांची, तो कल 10 बजे हम देखेंगे तत्काल खुल जाएगा, एक दिन पहले खुल जाता है।
उसमें क्या जो 2200 का टिकट है मेरा सेकंड एसी का, वो मिलेगा हमको 3200। तो वो पैसा बढ़ता है ना, तो आपको तत्काल पैसा देगा वो, ये बताइए। तो किसका पे करेगा आपको? नॉर्मली कैसे देगा ना पैसा वो, तो पहले पूछ ले, तो देता है देगा। तुम कम दिन में बोलोगे तो तत्काल नहीं होगा ना। हाँ, कम दिन में बोले तो आप देख लीजिए ना, कल देख लीजिए, नहीं हुआ तो कल रात में बुक कर लीजिए टिकट। कल रात को हम देख रहे थे पूरा पेट पर है ना। हाँ, आज छुट्टी था तो कितना बजे उठा कौन। देखिए चैतन्य वाला नोटंकी कर रहा मेरे हिसाब से। तो वो बोला था रेज्यूमे तो हम बात देखिए, वो एचआर वो बात करेगा ना, डिसीजन नहीं ले सकता, डिसीजन तो ऊपर मैनेजमेंट ही लेगा, मैनेजमेंट देगा, टीम को नौकर होता है। हां, बस वही ना बोल रहा है, वो एचआर को नौकर होता है। हां, बस वही चीज है। टीम क्योंकि आप एचआर को जो बोल रहे हैं ना, इस कंपनी के लिए हम एचआर को 3 महीना लगातार फोन किए हैं, मेरा होने के बाद बीच में मेरा फंस गया था। हम 3 महीना फोन किए, लास्ट में बोला एचआर बोला आज स्टॉक टू यू विल गेट इट नाउ, 3 महीने बाद बोल ये ऐसा कांटेक्ट किया था, बोला कि कल यहां पे आना, तो मेरे वहां एग्जाम से जल्दी तो इसके एचआर के थ्रू हुआ। तो अब हम बोले हम बोले वो टीम नहीं कुछ हो गया, तो ये बोला कि अच्छा हमको कल सुबह कॉल करता हूं, कॉल किया तो वो बात क्या बोला था, बीच से बात कर, तो आज कॉल किया तो वो उठाया नहीं। हाँ, तो संडे है, ऑफ ना, अपना ऑफ कल दिन भर में पुणे था। हाँ, तो कल फोन करेंगे, तो कल नहीं उठाएगा तो समझ जाएगा कि यहाँ से नोट कर ना, और फिर वहां से देखिए अगर आप चैतन्य के लिए रुकिएगा, आप बोले कि और सब कि आपको लीव हो गया, तो फिर इसको क्यों छूटा, आपको पैसा रिटर्न मिलेगा ही, तो ट्रिप मान लीजिए, फिर आप ट्रिप मान लीजिए, क्योंकि अब एक कंपनी के लिए बैटरी हो सकता, अभी आपको रोक कर रखेगा। नहीं नहीं, हम बोल रहे हैं सपोज कीजिए हम चैतन्य वाला, चैतन्य चैतन्य वाले हम आपको बोले प्लीज वेट फॉर अ वाइल, ठीक है, आपको बोले प्लीज वेट फॉर अ वाइल, आपको बोले हम आराम बोले थोड़ा देर रुकिए, ठीक है, आपको कंफर्म आपका कंफर्म है, रुकिए, कुछ टाइम बोले आप फोन किए हमको, हम बोले बिजी आपको बताते हैं थोड़ा देर में, फिर कुछ दिन बाद फोन किया तो सॉरी भी नहीं हो पाया, ये होता है लास्ट में देखिए लास्ट में क्या होता है, उसको नहीं तो बोलना और क्या बोलना, नहीं लास्ट में दिक्कत ना क्या लगता है ये सब आपका फील है मेरा फील हो, तुम्हें दिक्कत क्या लगता है इसमें कि लास्ट जो सॉरी बोलता है ना, उससे और गुस्सा होता है कि आप इतना टाइम मेरा बर्बाद कर दिए, बोल दिया कहीं गए नहीं, इससे बोले आपको छोड़ के चले जाता है। हाँ, ऐसा होता है।
Okay, so we are back again. So hello everyone, we are back again. Yes. So let's continue from there onwards. Okay, so let's continue now. Now we are on alike objects, isn't it? So we are on alike objects. So which type of alike object are we going to study? I am just trying to look. Okay, permutation of alike objects. This is what we are going to study. Okay. So if we are given an distinct object and distinct objects, okay, and p alike objects, and we are told to find the all possible arrangements, okay, then it is n plus p factorial upon p factorial. You should be knowing this, okay? Alike meaning same object. So one apple, they all are same, isn't it? So they are alike. So in this we can say n distinct object and p are alike, okay? We have n distinct object p alike, q alike, r alike. All possible arrangement are equal to n plus p plus q plus r factorial upon p alike factorial, q alike factorial, r alike factorials, isn't it? So this is the way it goes, okay? So I think this lecture is based on this only. Taken all at a time, taken some at a time, okay? Okay, okay. So taken all at a time. So here if you see, it is one, it is case one only, taken all at a time. This is case one, taken all at a time. Okay. So if you want one example, four apples, three guavas, oranges. Find total possible arrangements. Okay, so we'll simply do 4 plus 3 plus 4 upon 4 factorial, 3 factorial, 4 factorial. This is somewhere 11 factorial upon 4 factorial, 3 factorial, 4 factorial. Okay, this is 11. Okay, if you have 5 different objects, 4 apples, find all possible arrangements, which is 5 plus 4 plus 3 factorial upon 4 factorial, 3 factorial, which is what? 12 factorial upon 4 factorial, 3 factorial. Got it? In how many ways 3 red flowers, 4 yellow flowers, 5 white flowers, in how many ways we can arrange? Okay, so this is the question for arrangements. So part 1, 5 red rows, 4 yellow and 5 white. So total number of ways of arrangement is 5 plus 4 plus 5 factorial upon 4 factorial, 5 factorial, which is nothing but 14 factorial upon 5 factorial, 4 factorial, 5 factorial. Okay, flowers of same color are identical, so we took it identical, isn't it? Now second part, in how many ways this is possible if the white flowers are to be separated in any arrangement? Okay, so what will happen? We have 5 white flowers. So if you see, we have red, 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 yellow, 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 yellow. 4 red. So we have how many gaps? 1 gap, 2 gap, 3 gap, 4, 5, 6, 7, 8 gaps. So in 8 gaps, we'll put 5 flowers. So out of 8, we'll choose 5 gaps. Okay. And their arrangement is what? 5 factorial by 5 factorial. It is their arrangement is 5 factorial and they are same. So 5 factorial. Now the arrangement of 3 plus 4 say, flowers is what? 3 red. I think this was 3. I wrote 5. Okay. So if this is 3, this will be 3, this will be 12. Okay. And this will be 3, this will be 3. So we have red rose and 4 flowers. So their arrangement is what? This upon 3 factorial, 4 factorial, which is 8 factorial, 3 factorial, 5 factorial, 7 factorial, 3 factorial, 4 factorial. We can normally solve and get the value of this one. In how many ways the letter of word arranged can be arranged without altering the relative position of vowels? Relative position of vowels. So what will happen? It means that A, E. If you see any type of words, this should be in this way only. Okay. So what will happen? In arrange letter is how much? If you see arrange, it is A, R, R, A, N, G, E. So if you remove A, R, so 1, 2, 3 place removed. So we are left with 1, 2, 3, 4. So this is total 7 letters. So if we remove these 3 words, it is going to be this way. So what will happen? This is going to be 2R, 1N, 1G, isn't it? So in this merge, in this space, we'll find 1 gap, 2 gap, 3 gap, 4 gap, 5 gap. So in 5 gap, we'll choose 3 gaps and we'll place this one. So if we place in this way, then what is happening? It is going to have only the one format. There is no arrangement among them. So their arrangement is only one, because the different arrangement is going to have different relative position of vowels. Okay. So relative position of consonant should also be the same. That means it is 2R and G. R and G. So it will have to be in this way only. So their arrangement is also going to be only one. That means the answer is factorial, 3 factorial, 2 factorial. It is nothing but 10 is the answer. Okay. Okay, got it. So this is the answer. Okay, I'm just matching my answer. So what happened is that we misread this question. Misread in the sense, I consider that relative position. This solution is when relative position of vowels and relative position of consonant are same. Okay. So relative position of vowels, if you try to see relative position of vowels. So in this question it is trying to see that if here you have A, R, R, A, N, G, E. It is saying that this place, this place, this place should have only vowels. That means their arrangement is what? 3 factorial by 2 factorial, and the rest place should have only consonant. So their arrangement is what? 4 factorial by 2 factorial. If you solve it, it is nothing but 36. So this is what this question is trying to say. So what I solved is that relative position of vowels with respect to each other. So this is my thinking. This solution is for that. Relative position consonant with respect to each other. Okay. If that is the question, then we have to solve in this way. Okay. So I solved more in depth. Okay. How many words can be formed using the letter of the word assessment if each word begins from A and end with T? So the word is A and ending with T. In between, how much words we are getting? We are getting 2S, 4. We are getting 4S, 2E, 1M, and 1N. So their arrangement is what? 4 to 6, 6 to 8. 8 factorial upon 4 factorial, 2 factorial. Okay. So this is the answer. And you know that factorial could be written as this 8 factorial upon 4 factorial, 2 factorial. Okay, solve it. If all the letters of are arranged in all possible ways, in how many of the word A's are not together and also R's are not together? That means what happened? Total number of arrangement, total numbers of arrangements of arrange is how much? The letter is 3, 3, 6, 7. 7 factorial upon 2 factorial, 2 factorial. This is the total number of arrangement. Now what will happen? We are told that 2 A's and 2 R's should not be together. So when 2 A's and 2 R's are together, So we have what? 2a, 2r, and then 1n, 1g, 1e. So if we consider this as one identity, two identity, 3, 4, 5. So their arrangement is what? 5 factorial upon no, it is they all are the same. Yes, it is one unit. So no arrangement. Okay. So this is the way when they all are together. So number of words in which in which two A's and two R's are not together. Okay, is what? 7 factorial, 2 factorial minus 5 factorial. Okay, so this is the answer. If you solve it further, it is going to be 840. Okay, let's move ahead. Number of ways of taking four words. So we already took such type of question. Okay, in which starts as well as and with T. We already took this question. In how many ways can I, and how many words are there in the list before the first word starting with M? So this we can solve it. Okay, so we can solve this. Okay, how many permutation of the word 19 with no two e's together? So we have three e's. Okay, so we'll take this question. We have in 19 we have 3n, 3e, 1i, 1t. So we have 3, 3, 6, 7, 8. 8 numbers. Okay, so two e's are together. No two e's are together. So when no twos, so total number of words possible is 3, 3, 6, 7, 8. 8 factorial upon 3 factorial, 3 factorial. Yes. Okay, and numbers of words all three e's are together is 3 e's together, and we have, this is one identity, we have 3n, 1i, 1t. So it's like 3, 4, 5, 6. 6 factorial upon 3 factorial. And now numbers of words in which 2e and 1e are separated. So there is 2e, 1e, 3n, 1i, 1t. So we have 1, 2, 3 to 5, 6, 7. 7 identity. So we are getting 7 factorial. No, 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 no. We have 2e and 1i. Yes. And we have 3, 4, 5. So 1, 2, 3, 4, 5. 5 things are there. We have 1, 2, 3, 4, 5, 6 gaps. So we'll choose 6C2, place both of them, and their arrangement will be 2 factorial, and their arrangement will be 5 factorial by 3 factorial. Yes. So now total possible arrangements in which no two e's are together is total number of possible words minus no three e's are together. All three e's are together minus all two e's are together. So this is the answer. Okay. So this question has been done. Two identical balls, three red balls, four green balls. The number of ways in which they can be arranged in a row that so that at least two balls are separated from the balls of same color. At least one ball is separated from the balls of same color. Okay, so we are going with this one. We have two white ball, three red balls, four green balls. So what will happen? We are told that at least. So we are told that at least one ball is separated from the balls of one color. So at least one separated, at least two separated, at least three separated. That means can we say that first we'll do total numbers of possible arrangements. If you say it is 2 plus 3 plus 4, which is 9 factorial upon 3 factorial, 4 factorial. So this is the total number of possible arrangement. And now when all balls of same colors are together, So we have only this, which is two white, they are together. Okay, this three red, this four green. Now if you do their arrangement, we have just 3 factorial, if you remember. Yes. So if this is minus, this case is minus from this case, then we can get that at least one ball is separated. So total arrangements of at least one ball of same color is separated is 9 factorial, 2 factorial, 3 factorial, 4 factorial, minus 3 factorial. Okay. Okay. This is the answer. This question, solve it as a homework. This question you can solve as a homework. We have already covered. So it's a JEE Mains question and it's a JEE Mains time. We should take this question. We have 10 white ball, 9 green, 7 black. So total number of ways in which one or more ball could be selected. So what can happen? Selecting the quantity of ball. If we have 0 ball, 0 white ball, okay, 0 white ball. If we have 1 white ball, if we have 2 white ball, if we have 10 white ball, okay, this could be the way. If we do it, we have 0 green ball. If we have 1 green ball, numbers of ways total numbers of base ways, uh, it is a total number of ways, uh, at least no or more balls could be selected. So in this, what will happen when we have 0 ball, 0 ball, 0 ball? So no ball is selected. Other than that, we can have, if we do any multiplication, we are going to get more balls. So no or more balls. So ways, numbers of ways of selecting one or more balls is what? This is 110, 880 minus 1. This is the case where when no balls selected. Okay, so this is 8, 7, 9. Got it? Solve this question as a homework. Okay, solve this as a homework. Okay, solve this as a homework. Solve this as a homework. Solve this as a homework. Solve this. So I will take this question as a classwork. Okay, how many ways there are to invite one of the three friends? So there is F1, friend 1, friend 2, friend 3. For dinner on successive night, 6 successive night. We have 1, 2, 3, 4, 5, 6 nights. Okay, such that no friend is invited more than 3 times. Okay? So what can happen? So if we give one of the friend 3 nights, okay, and the other friend 3 nights, one friend will get 0. If we choose do what if we do what? If we give it 3 nights, 2 nights, 1 nights, that is okay. If we send it more, it will become 1 2. Okay, and the third possibility is 2 2 2. So this is the possibility. So what will happen in this? We'll choose any one of the friend who is not going to enjoy the night. That means this friend, and the other friend is getting 3 3. That means their arrangement is 6 factorial, 3 factorial, 3 factorial. In this, all friends are getting. So what will happen? The arrangement of this number is what? 3 factorial, because this could happen among 3 friends. So 3 factorial. And now the arrangement of the nights are what? 6 factorial, 3 factorial, 2 factorial. So this is the way in which the nights, in which these numbers are going to be distributed among them. So 3 factorial. And now when if it is F1, 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 and this is F2, F2, F3. This is F3. Okay. So their arrangement is what? 6 factorial upon 3 factorial upon 2 factorial. Now in this way, the arrangement of this number is what? 3 factorial by 3 factorial, which is 1. And night's division are what? 6 factorial, 2 factorial, 2 factorial, 2 factorial. So total number of ways are how much? 3c1, which is 3, 6 factorial, 3 factorial, 3 factorial plus 6 factorial by 2 factorial plus 6 factorial by 2 factorial cube. This is the answer, okay? This question solve as a homework. This question solve as a homework. This question solve as a homework. This question we already solved. So this question I am trying to take. So this is a 7-digit numbers. 1, 2, 3, 4, 5, 6, 7-digit number. And it has to use only 1, 2, 3. And the sum has to come out to be 10. So if you take one arrangement, it is 1, 1, 1, 1, 1, 1. So 6 plus 3, 9. It is not going to be 10. It is not 10. So it is 1. It is not equal to 10. Okay, it is not 10. So it is 1, 1, 1, 1, 1, 2, 3. It is going to be 10. So one case is this. Second, second is what can happen? We can have 3, 3, 3, 9, 1, 10, all 0, 0, 0. So this is the possibility. We can have 3, 3, 2, 2. This is the possibility. We can have 3, 3, 2, 1, 1. Okay, 0, 0. We can have further possibilities. 3, 3, 3, 2, 2, 1, 0, 0. We can have second possibility. 3, 2, 3, 3, 1, 1, 1, 1, 0. We can have next possibility. 3, 2, 2, 1, 1, 1, 0. We can have next possibilities. If we give 1 to 1, this one to this one to this one, we are going to be the same. So it is 2, 2, 2, 2, 1, 1, 0. And ninth, we are going to have 2, 2, 2, 1, 1, 1, 0, 1. Okay. And the next one is all possibilities same. So we have this much possibilities. So their arrangement is how much? 8 factorial upon 1, 2, 3, 4, 5. 8 factorial upon 5 factorial. This possibility is how much? This possibility is 8 factorial upon 3 factorial 3 factorial. This is 7 factorial. Okay, this is 7. This is 7 factorial. 7 factorial upon 3 factorial, 3 factorial, minus when 0 is here and all numbers are there, then we have 6 factorial upon 3 factorial, 2 factorial. Similarly here 7 factorial, 3 factorial, 2 factorial, 2 factorial, minus when 0 is there 6 factorial, 2 factorial, 2 factorial, 2 factorial. This one 7 factorial, 2 2 2, 2 factorial, 2 factorial, 2 factorial, minus 6 factorial upon 1 factorial, 2 factorial, 2 factorial. This case 6 factorial, 3 factorial, 2 factorial, minus 5 factorial, 3 factorial. So 616 case we are writing here 7 factorial upon 4 factorial, 2 factorial, minus 6 factorial upon 4 factorial, 2 factorial. Okay, now seventh one will come out to be 7 factorial upon 3 factorial, 2 factorial, minus when 0 is there 6 factorial upon 3 factorial, 2 factorial. Eighth 7 factorial, 4 factorial, 2 factorial, minus when 0 is there 6 factorial upon 4 factorial, 2 factorial. Ninth we have 7 factorial, 3 factorial, 4 factorial. In order to get the answer, add all the numbers. We will get the answer. Add all the cases. This one solve as a homework. This one solve as a homework. This solve as a homework. Solve as a homework. Solve as a homework. Taken some at a time. Taken some at a time. Now we have M distinct object and identical P alike, alike meaning identical only. So what will happen? We have to form, we have to make somewhere, we have to choose M plus 2, we have to choose M plus 2 objects and arrange. So normally we in this type of question will have to go with the cases. So M distinct object. So what can happen? We can choose N element from here, P element here from here. I will go with the question only. So question meaning example. 4 apple, 5 different fruits. Okay. Find ways of selecting selecting 6 fruits and their arrangements. Okay, so what will happen? For 6 fruits will have 4 apple and 1 fruit, which is 4C4. Taking 4 fruit is one time only, and here it is 5C1. Their arrangement is 5 factorial upon 4 factorial. This is first case. Second case, 3 apple, 2 different fruit. So taking 3 apple is one time, all are identical, and 2 fruit, 5 seed true, and their arrangement is 5 factorial upon 3 factorial. Third one, 2 apple, 3 fruits. So choosing 2 apple is only one time, and 5 seed 3. Their arrangement is 5 factorial, 2 factorial. Fourth one, 1 apple, 4 fruits. Okay, so it is 1 apple is one way, 5 fruits is 5C4, and their arrangement is 5 factorial. Fifth, 5 different fruits. So 5 different fruits, 5C5 and 5 factorial. So total possible ways are how much? It is 5 into 5 plus 5C2, 5 factorial, 3 factorial plus 5C3, 5 factorial, 2 factorial plus 5C4, 5 factorial plus 5 factorial. So these are the different ways. Okay, so let's take this example. Find the number of ways of selection of one or more letters from this. No restriction. So what will happen? In this we have 4A, 2B, 3C, 1D, 1E, 1F. Yes. So selecting no A is A to the power 0. Selecting 1A is A to the power 1. Selecting 2A is A to the power 2. 3, 4. Similarly, selecting no B, selecting 1B, selecting no 2B only. Okay. Now selecting no C, 1C, 2C, 3C. Selecting no D, selecting 1D, selecting no E, selecting 1E, selecting no F, selecting 1F. So what will happen? This is the way of selection of no one. This is the way of selection of no or more than no. Selecting none or more than one. So this is the way it is what? Selecting no or at least one. Okay? At least one letters. Because what will happen when we multiply this? And in case it comes out to be A note, B note, C note, D note, E note, F note. What will happen in that time? We have no letter selected. So total ways of selecting at least one letter is what? This is what? 1, 2, 3, 4, 5. 5 into 1, 2, 3. 3 into 1, 2, 3, 4. 4 into 1, 2 into 1, 2 into 1, 2 minus 1 in which none is selected. So it's simply 15 4 ja 60, 68 ja 480, 479 is the answer. If you see answer is matching, isn't it? This answer is matching. So letter A and B are selected at least once. So at least one meaning it should start with A1, A2, A3, A4 and B are selected at least one. So B1 plus B2 and here we have the similar this thing which is C note, C1, C cube, D note, D1, E note, E1 and F note, F1. So it is simply 4 into 2 into 4. This is 4, yes. Into 2 into 2 into 2. If you see it is what? 8, 16, 8 ja. 1, 2, 3, 4. 16, 16 ja. 256. Answer matched. Only one letter is selected. So only one letter is selected. That means out of 6, we are selecting one. That means anyone. Either we take A or B or C or D or E. Okay. So 6 C1 which is 6. At least two letters are selected. Okay. Fourth one is so at least two letters are selected. That means what? Hmm. At least one letter selected is this one. Yes. At least one letter selected is 497. No letter selected is 1. So see, total numbers of ways are how much? Total number of selecting no, none or none, some, all is 480. Number of ways of selecting at least one. It is at least two, isn't it? So number of ways of selecting one number is 6. So selecting of exactly one number is 6 and selecting no number is 1. So if we minus them, we are going to get selecting of at least two number, isn't it? So select no number, select exactly one number. If we minus them, we get selecting exactly at least two number. Okay, this one. Find the number of selection of at least one vowel and at least one consonant from the word triple. So in triple we have one T, one R, one I, one P, one L, one E. Okay. So we have to select vowels. If you see vowels, we have I and E. If you see consonant, we have T, R, P, L. So at least one. That means at least one, meaning this is 2. So it should be 2C1. Okay, if you have any one of these 2C1 dot 4C1. Okay, this could be 2C1 4C1, or we simply write it is 2C1 2C2 multiplication with 4C1 4C2 4C3 4C4, and you know that this is 2 square minus 1, this is 2 to the power 4 minus 1, so it's simply 15 into 3 45 is the answer. The number of ways, 5 letters that can be made with this. Okay, so we have solved such type of problem earlier. Number of permutation of which can be formed out of the letters is taking 3 letters together. So okay, this question I am going to do. We have a word series 2S 2E 1R 1I. Okay, this is series. Okay, the number of permutation which can be formed out of the letters of the word taken 3 at a time. So we have to make 3 letters. So I think this question is falling in this, which is taken letters some at a time. So 3 letters could be what? All unique letters, one different, one different, one different. That could be 4C3, and their arrangement is 3 factorial. One different, 2 same. That could be possible like first working with 2 same. So 2C1 we chose 1, and now out of 3 we'll choose 1, and their arrangement is 3 factorial 2 factorial. Now 3 same, 3 same, not possible, not possible. Okay, so total number of arrangement, if you calculate this, it is what? 24 18. So if you add it, it is 42. So this is the total number of formation. Okay, now we are on lecture 5. Okay, lecture 5 is smaller. If we are done with this, we'll move to formation of groups. Selection of one or more objects. Let's wait. Okay, so this is very small topic. Okay, So if we are told that we have n different objects and we have to select one or more selection and different object one or more selection. So what can happen, we can choose one element, we can choose two element, we can choose three element, we can choose four element, we can choose an element. So if you see, it is simply 2 to the power n minus 1, isn't it? If we have an identical object, so what can happen? If we have an identical object, we can have 1a or 2a or 3a or 4a or na. So selecting is what? This is counted as 1, 1, 1. So this is 1, 1, 1, 1, dot, 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 1, which is equal to n. So from n identical object, if we are selecting 1a, it is only one type. We require only one way to select. If we are selecting 2a, so we'll just take 2a. So we have to take just 2a, all are same. So it is only one type, okay? So this is what we are trying to say. Now selection of 0 or more object out of n identical. So now we got the case of n identical. N identical objects. So no selection. No selection is what? N identical. We'll say that it is A up to an. Okay, they are identical. So no A is selected. A to the power 0. One selection. A to the power 1. Two selection. A square. So it will go up to n. N selection. A to the power n. Dot 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 dot. So selecting no A is selecting one A. All are identical. So we select any one. That is correct. So this is also one. This is also one. So if you see, it is going to add up to n. So there is n different methods to select 0 or more objects out of n identical. Got it? Now selection of one or more object out of n identical. So what will happen? One or more. If we have P alike, that means P same, Q same, R same, S different. So S element are same, yes. So out of S we are selecting no element. Out of S we are selecting one element. Out of S we are selecting two element. Also, out of S, we are selecting three elements. It will keep on going. Out of S, we can select all element. Here, we can select no element in P to the power 0, P to the power 1, dot dot dot, P to the power P, all elements selected. Yes. Similarly, Q to the power 0, Q to the power 1, Q to the power Q, all elements selected. This is R to the power 0, R to the power 1, dot dot dot, R to the power R, all elements selected. So what will happen? This is the process where none, some, or all elements. Okay. So, okay. So this is the way in which there is no element here, there is no element here, there is no element here, there is no element here. So this could be one of the case. So for one or more of selection, can we say this answer is 2 to the power s, and this is p to the power p, which is p plus 1. This is q plus 1. This is r plus 1 minus 1, in which none case is selected. Okay. So this is the required answer for our this case. Okay. Let's move ahead. So 12 different objects are there. 12 different objects are there. Okay. So 12 different books are in shelf. In how many ways? At least one of, we can select at least one of them. So we can say 12C0, 12C1, 12C2, 12C3 plus dot 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 12C12, which is what? 2 to the power 12 minus 1. Okay. Or we could have told that this is the way. Okay, we have to select at least one, at least two, at least three, up to at least 12, and this is what? 2 to the power 12 minus 1, if you know from binomial theorem. Okay. There are 11 fruits in a basket, of which 6 are apples, 3 are mangoes, 3 are apples, 3 are mango, 6 are apples, 3 are mangoes, 2 are bananas. Fruits of same species are identical. How many ways are to select at least one fruit? So at least one fruit meaning no apple, one apple, two apple, three apple, four apple, five apple, six apple. No mango, one mango, two mango, three mango. No banana, one banana, two banana. Minus when none is selected. So if you see it is 7 into 4 into 3 minus 1, which is 83. Okay. If a self in a self, if there are 6 physics, 4 chemistry, 3 mathematics books, how many combinations are there if books of same species are different? So books of same species are different. That means all are different. Yes. 6 plus 4 plus 3 factorial, which is 13 factorial. If books of same subjects are identical, so this is the question from combination. If they are identical, 13 factorial, 6 factorial, 4 factorial, 3 factorial. Got it? So let's move ahead. 5 apples, 4 mangoes, 3 bananas. In how many ways at least 2 fruits of each variety is selected? Okay. Fruits are of same identity. Okay. So one good question. We have 5 apple, 4 mango, 3 banana. So at least two identity. That means it should be a square, a cube, 2 apple, 3 apple, 4 apples, 5 apples. We have 2 mango, 3 mango, 4 mango, 2 banana, 3 banana. So if you see it is 1, 2, 3, 4. 4 into 3 into 2, 24. Okay. Now fruits of same species are different. Okay. So when we are selecting 2 apple, we will go with 5C2. When we are going with 3 apple, 5C3. When we are going with 4 apple, 5C4. When we are going with 5 apple, 5C5. When we are going with 2 mango, 4C2. Out of 4 we are taking 2 mangoes. Out of 4 we are taking 3 mangoes. Out of 4 we are taking 4 mangoes. Now we have banana to take from 3. From 3 banana we are taking 2 banana. From 3 we are taking 3 banana. So if you calculate, it is simply 5 factorial upon 2 factorial is 10. This is 10. This is 5. This is 1. And here it is what? 6, 4, 1. And this is 3 plus 1. So we have 26, 11, 4. So this is the total number of possibilities. Okay. Multiply it and calculate it. Okay. We are moving to lecture 6. What do you think? We have completed lecture 5. Should we move ahead or not? Okay. If you move with lecture 6, okay? 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Okay. So it's a 7. We started our journey from 11. Okay. So after 6 hours of journey, we are going to take a pause